So good, good day to everyone who's watching this video. This is our algorithms and complexities project under Max, and so our project is all about creating algorithms, and so we chose three categories, which are sorting algorithms, searching algorithms, and then graph traversal algorithms. And so first we have our sorting algorithms, in which we have three sorting algorithms. So first we have our selection sort. So in our selection sort, we have an input number or input field, and then the rest we have our output fields. And so what this does is we input our numbers over here, and then it will create a visualization, and then it will generate the time and the steps it took to generate, or the steps that it took to fully sort our number or our list of numbers. For example, here, if you create a number or a list of numbers that are not sorted, let's not do that. For example, just for example, now it just creates a box or a list of boxes based on your input numbers. So you have to remember that this should be separated by comma. And so if we click next and in this part, it will first go through the sorting algorithm step by step, wherein red means that it's visited. So if we just click next, it will just try to sort step by step. And so after it does like a full iteration of the first step, that number will become green, which means it's sorted. So in selection sort, it just scans through the whole list and finds the smallest number, and then puts it in the index of the current index. And so you can just click next and next until it finishes. So you can also go back if something goes wrong, because if you click next too fast, it breaks the whole program. For example, if I spam this, of course the website will break. So for our next sorting algorithm, we also have insertion sort. Again, we can input our random numbers, and this time it will just do another sorting algorithm, which is called insertion sort, in which it will insert the numbers and then just rearranges them once it goes inside its own sorted list. Like for example, like so. And so we also have our last sorting algorithm, which is bubble sort. Let's input our list of numbers. Give me a second. Like so. And this time it's the bubble sort. So in bubble sort, it's like you're just dragging along the highest number, and then that highest number should be placed on the very rightmost of the array. And so, for example here, we should be seeing the 8 on the very right side, since that's the highest. And so since it's already on the right side, we can just keep clicking next, and no swaps will be involved. I mean, there was a swap involved, but I mean the 8 wasn't swapped. So you can keep going until it's sorted. Even though it's already sorted, it still has to check one by one. But then, if the program sees that there was no swaps in the whole array, it must mean that it's already sorted. For example here, in this part of the iteration, since there was no swaps involved, like for example 1 and 2 wasn't swapped, 2 and 4 wasn't swapped, 4 and 5 wasn't swapped, that must mean that the array is sorted. That's why you can't click next anymore. So let's move on to our searching algorithms. So first we have our linear search, in which we can put our array of numbers. For example, let's create a list of numbers from 1 to 10. 6, 7, 8, 9, 10. And then let's say let's search for number 9. So in this algorithm, it will just search the numbers step by step linearly. That's what linear search means. It just iterates through the whole array one by one until it finds the number. So let's move on to binary search. Now in binary search, it's a bit more complex, because what it does is it just splits our array in half. For example, here in the range of 1 to 10, we want to search for 7. So binary search is like how you would search in, for example, a dictionary, wherein you try to split the book into half every time until you find the correct page. Like for example, if let's say you're searching for the letter or the word, let's say visualization. So to find the word visualization in a dictionary, you would first need to go to the pages where V is the first word. So you would try to estimate the middle, right? Like so, if you go in the middle, you split the page, and then you eliminate the left side, and you just start searching the right side, since that's where V is. And then once you split it, your search becomes smaller and smaller by half every time. So in a sense, that's what binary search means, wherein you're just splitting your array into halves every time. For example, here in 1 to 10, we're searching for 7. So at first it searches for 5, since that's the middle, and then once it searches for 5 and it's still not, let's say if our highlighted number is less than our target number, it will set our low index in this part, and so this time it will search from 5 to 10, and so it will try to find, or now try to search between 5 and 10 and find what's in the middle. So for example, here in the middle of 5 to 10, the algorithm or the code found that the middle is now 8. Now since the highlighted number is now 8, it will now try to search from 5 toward 8 this time. So if we click next, now it's 6. This time it will now search from 6 to 8, and then we find 7. And that's basically how binary search works. It just creates halves of your array until it finds the number. So in this algorithm, it should be noted that your array must be sorted, but in this project we also took care of that by adding a sorting function. Lastly, we have our graph traversal algorithms, in which we have only two, which is depth first search and breadth first search. And so for our depth first traversal, or DFS, we don't have an input field, but instead we have our canvas over here, in which we can create or add our nodes. And then with those nodes together, we should want to create a edge between them. And in order to create an edge between them, we can just highlight two nodes together and we'll just create an edge. And for example, let's just create a tree, but it doesn't have to be necessarily a tree. You can create a graph if you want, but for the sake of this video, we'll just create a tree like so. So for our depth first traversal, what it does is just it digs towards the least the leaf node, and then it just finds it just goes really deep down into the graph. So in order to start this, we have to click the root node and click start, and so we can just click next. Like for example, this is what DFS does. So it goes from 1 to 2, and goes to 4, and then goes to the next leaf node, and then it backtrack back, and then goes back to another node until it reaches the bottom. So to further explain, let's have another example. So if we do this, it should just dig for the lowest node, for example. So that's DFS. Next up, lastly, we have our breadth first traversal, which is another graph traversal algorithm in which it searches, or it traverses through the whole graph in a level by level manner. So instead of searching it for the deepest node, it will search every node in every level one by one. So to visualize, this is what it looks like. So this is our level 1 or level 0, and this is level 1, this is level 2. And so first it highlights every node in our level 0, and then next it highlights the nodes in our level 1, and then so on. And that's basically breadth first traversal. And to explain how it works, basically is it basically is a an algorithm in which we use a queue, and then we just enqueue the children of our root node, and then we go to those children, and then we then enqueue its own children. But then since we already queued our first two children, we have to traverse through those first, and so we're just basically inserting the new children to our array. But before traversing into them, we have to traverse the first children that were enqueued, since it's a first in first out traversal. So that's all for our algorithms and complexity project. Thank you.